So just some quick tricks following on from looking at solving equations that can kind of speed up the process, and you're going to have to learn them eventually just because it saves a lot of time, and you need the time when you're solving these kind of equations. So if you want to get rid of a number from one side of the equation, you can move it, quote unquote, to the other side by doing the opposite operation. And I'll explain what do I mean by opposite operation. So let's say we had this example, x plus 9 is equal to 12. Now straight away you'd start saying, okay, I want to isolate x by himself. So there's a plus 9 here, I want to get rid of that plus 9. How am I going to do that? Okay, well, I could do this. Now what happened here was I moved the 9 over. Now I'll talk about what I mean by moving. And it changed operations. So see the way it was plus here? If I bring it across the equal sign, it becomes a minus. It becomes minus 9. Now you're probably wondering, what is going on here? Why does that happen? Well, remember when we were solving equations where I wanted to get rid of 9, and I subtracted 9 from this side, and I subtracted 9 from this side. Well, when I subtracted 9 here, it just became 0. So I just got x. And when I subtracted 9 over here, well, it was 12 minus 9. So all I've done is just skipped a step. And by skipping a step, I'm just using this kind of way of remembering where if I move something over, it becomes minus 9. So now I have x is equal to 12 minus 9. Well, that means x is equal to 3. What about this example then? 2x minus 5 is equal to 7. So again, we want to isolate the x's. So I'm going to say 2x is equal to 7 plus 5. Now what happened was I moved this minus 5 across the equal sign, and it does the opposite operation. So since it was subtracting 5 here, it's going to add 5 here. Now again, remember why this is the case. I'm adding 5 to this side, I'm adding 5 to this side. They just cancel, but it's 7 plus 5 then over here. So I'm just skipping the step. Okay, so I have 2x is equal to 7 plus 5, so that's 2x is equal to 12. Now I don't want 2x, I want x by himself. Now remember, this is 2 multiplied by x is equal to 12. I don't want 2 multiplied by x, I want x. So what happens if I bring the 2 over? Well, it'll divide by 2. So remember, it was 2 multiplied by x. If I bring it over, it does the opposite operation. It divides by 2. So I get x is equal to 12 divided by 2, which is just x is equal to 6. Now, why does it change? Remember when we wanted to get rid of the 2 multiplied in previous examples, we did divide it by 2. We divided both sides by 2. So when we divided this side by 2, we just got x. And we divided this side by 2, well, we got 12 divided by 2. So again, all I'm doing is just leaving out a step, kind of. I'm just skipping ahead. So then I get x is equal to 6. Okay, the last example we kind of looked at was a third x plus 3 is equal to 7. Now again, I want to get rid of this 3, so I'm going to bring it over. So it's plus 3, so it's going to become minus 3. It's changing the operation. So then I have a third x is equal to 7 minus 3, which is just 4, yeah? Now, I don't want a third x, I want x. Now, think about it. What's happening here is this is dividing. So this is the same thing as x divided by 3, yeah? So if I bring this 3 over, what happens? If it's dividing, it goes over, it becomes the opposite operation. So it's going to multiply. So be careful now. We're not multiplying by a third. That's not what I'm saying. I'm bringing this 3 across, because I'm leaving the 1 kind of there. I'm bringing this 3 across, and it's multiplying. So I get 3 times 4, which is 7 minus 3. So then I get x is equal to 12. Just again, I'm going to be careful. I'm going to say this again. It's not that we just bring this 3 across. That's not what we're doing. this is dividing by 3. A third multiplied by x is just x divided by 3. So if I multiply by 3, I'm going to get rid of this third, remember? So a third multiplied by 3 is just 1. So if I multiply this side by 3, I have to multiply this side by 3. And that's what's going on here. I've just multiplied this side by 3, and I multiplied this side by 3. And then I've cancelled this fraction, and I've got 3 times 4. When I say cancel, it's just become 1. So 1x. This is the most important kind of thing to learn. You'll eventually just get used to these kind of quick tricks, but just really, really important that you remember why this is the case. So why is it when I move the 9 over here, does it become minus 9? Why is that? Well, remember, we're just subtracting 9 from both sides. Because an equation, whatever you do to one side, you have to do to the other side for it to stay balanced and stay an equation. Okay, here are some recap questions that you can look at, and I'll give you some time to do them. So, solve for x. I have minus 2x plus 3 is equal to 6x plus 2. So this is a tougher example. So you notice I say solve for x. What that means is just find x equal to something. Now, I have a long explanation here. I want the x's on one side and the constants on the other side. That's what we call isolating. So I'm going to bring all the x's to one side and the numbers to the other side. I've chosen to bring the x's to the left hand side. If you wanted, you could bring the x's to the right hand side and all the numbers to the left hand side. That's fine. Whatever you like, as long as you get x equal to something. And remember, if I have x on the right hand side of the equation or the left hand side, doesn't matter, as long as you just have x equal to something. Okay, so I have minus 2x plus 3 is equal to 6x plus 2. I'm going to bring this 6x across the equal sign. So remember, this is 6 times x, and it's plus 6x. So it's plus 6x plus 2. If I bring it across, it becomes minus 6x. Yeah? Now, you're going to be saying, sir, well, why am I not dividing? I'll divide this whole thing by 6. Well, we only start dividing when we have x's on one side and constants on the other side. First, I need to get the x's by themselves. So all I'm doing is moving this 6x. I'm not worrying too much about the 6. I'm just moving the whole thing. So I'm going to bring it over so it becomes minus 6x. So I have minus 2x minus 6x. The plus 3 stays there and the 2 stays there. Okay, what's minus 2x minus 6x? That's minus 8x. Minus 2 minus 6 is minus 8. Plus 3 is equal to 2. Then I'm going to bring the 3 over. So what's plus 3? I bring it across the equal sign. What's going to happen? It's going to become minus 3. So 2 minus 3 is minus 1. So I have minus 8x is equal to minus 1. Now, I don't want minus 8x, I just want x. So this is minus 8 multiplied by x. If I bring this minus 8 over, so I'm leaving the x by himself. Now, this is when I can divide by the coefficient. So I didn't do it up here. I did it down here when I had the x's on one side, the numbers on the other side. That's when I worry about the coefficient then. So I have minus 8. I divided 8 by minus 8 when I brought it across the equal sign. So it's minus 1 divided by minus 8. Now, minus 1 divided by minus 8 is just 1/8 because a minus divided by a minus is a plus. So I get x is equal to 1/8. Now, how will I check this? All you have to do is put in x equal to 1/8 back up into here. So it's minus 2 multiplied by 1/8 plus 3. Is that going to be the same thing as 6 by 1/8 plus 2? So try it out. See if it's correct. So where did they go wrong? This is the next one now. Well, think about it. I had minus a half x plus 1 is equal to 4. I brought the 1 over because I want the x's isolated. So I brought the 1 over. So that's fine. It became a minus. That's okay. I have minus a half x is equal to 3. Now, I don't want minus a half x. I want just x. So remember, when we have fractions, we're going to multiply by something to get rid of the fraction. What am I going to multiply by? Well, minus a half x, if I multiply it by minus 2, or another way of thinking about it, if I bring this minus 2 across, what's going to happen? Well, it's going to become multiplying by minus 2. So you'll see there, it's only plus 2. So we've made a mistake. That should be a minus. With these fractions, think about it. That minus can be with the 1 or with the 2. In this case, I'm taking it with the 1, so I bring it across. So it'll be 1x and then divided by minus 2. So if I bring this dividing minus 2 across, well, it's going to be becoming multiplied by minus 2. Now, I understand a lot of people aren't comfortable with these kind of fractions. So again, if you don't really like the whole bring it across idea, just go back to the original concept that this all derives from, where if you have minus a half x, I want to somehow change this to 1, plus 1. What will I multiply this by to become plus 1? Well, if I multiply it by minus 2, it becomes 1. Yeah, because minus a half multiplied by minus 2 is 1. So then if I multiply this side by minus 2, I have to multiply this side by minus 2. So that's where this minus 2 comes from. Okay, I have minus 2 times 3. Well, that's actually going to be minus 6. So I've made a mistake there as well. That should be x equal to minus 6.